A rock is thrown upward at 35 meters per second and at a height of 22 meters. Its position function is s of t equals 22 plus 35t minus 4.7t squared, where up is plus and down is minus. Determine its max height to nearest hundredth. So if we just sketch the scenario here, we're looking at a situation where we have time on the x-axis and the position of the rock on the y-axis. It is thrown from a height of 22 meters. So it's looking something like this. We're looking for the maximum height. So we're looking right there, the y-coordinate of the vertex. So that's your max height. At the max height, the velocity will be 0. So and that simply means that a tangent at maximum height will have a slope of 0. So at maximum height, the velocity equals the derivative of the position function, and that's going to equal to 0. So let's differentiate the position function. So our velocity equals the derivative of the position function, which is here, and that's simply going to be 35 minus 9.4t. Okay, and now we're going to set this to 0. So we're going to set v of t, the velocity function, equal to 0, which is going to be 35 minus 9.4t equals to 0. And now I solve it for the time, which is going to give us negative 35 over negative 9.4, which is equal to, and to nearest hundredth, so 2 decimals, 3.72 seconds. Now, so this tells us that after 3.72 seconds, this rock reaches the maximum height. Now, we actually want to know the maximum height, so now we have to go back to our position function and determine the max height. So that's going to be s of 3.72 equals 22 plus 35 times 3.72 minus 4.7 times 3.72 squared. And if we evaluate this to nearest hundredth, it's going to be 87.16, and the units are meters.